I want to talk a few minutes about the validity of inference. That is what this chapter is all about. So I'm going to pull out the major points in the chapter, provide an overview of what you read in more detail when you read the chapter. Validity means essentially truth or correctness. What we say in more modern terms is that we're looking for a correspondence between how we describe how things work, that's typically done within our theories, and how they actually work in the world. So you see here there's a philosophy of realism that is presupposed before we start looking at validity. That is, there is the way something works and how it exists in the external world, but then there's our understanding of how that works. And the closer we can match our understanding with what we observe at work in the world, the more valid our research findings. We typically talk about 4 types of research validity. Again, a more modern view is that research validity requires us to establish evidences of validity. And there are different aspects to the kinds of evidence that we can find that we're in fact creating a correspondence between our theory and our observations. I find it useful still to talk about these in terms of types of validity, and you'll see it frequently in the literature, and if you were to do a web search, you'll see these frequently referred to as types of validity. But in the back of our minds, realize that we're really interested in this correspondence of our understanding with actual reality, and it's hard to partition that into types. So really, there are various types of evidence. And so you'll sometimes hear me refer to particular types of evidence of validity rather than types of validity. Nonetheless, it's useful to sometimes talk about types of validity, and I find myself doing that, slipping back into those patterns. And I think that's something that's going to be around with us for a long time. But I hope you understand what I'm trying to explain here is that you have a degree of correspondence between what you theorize, how things work, and how things actually work. And what we're trying to do is to amass evidence that there is this correspondence. And amassing that evidence takes on various forms, which we're here calling types of validity. Let's review briefly what each type means. Statistical conclusion validity is asking the question, are we correct when we reach conclusions about the relationship of variables that we're studying? Are we, in fact, when we say that there is a particular relationship among variable A and B, does that relationship actually exist? When we talk about the effect size of a treatment, are we, in fact, getting at the actual size of the effect? So really, this is a correspondence between our statistical findings and again, what actually exists. So statistical conclusion validity, in sum, is about whether we are making correct statements about relationships, whether when we say that there is a relationship, there really is, or when we say the relationship is a large relationship or a strong relationship, it truly is. Whereas statistical conclusion validity is about relationship, internal validity is about the nature of that relationship. Is it one of cause and effect? As you all know by now, because you've had enough statistical training to know this, you can have relationships that are not due to one variable causing a change in another variable, but rather the two variables co-vary because of some third extraneous variable. Internal validity has to do with whether we can establish that changes in one variable are causing changes in another variable. So it is about cause and effect. Obviously, if we're doing research and what we're trying to do is just establish a relationship, not a causal relationship, then internal evidences of validity become less important in establishing research validity. But if what we want to do is know how one variable, when it changes, will result in changes in another variable in a causal form, which ultimately is what's going to allow us to control our environment, then we do have to be concerned with the internal evidences of validity. Construct validation is about whether we are correctly interpreting the nature of the constructs that we're describing in our theory. And these constructs can come in two major forms. They can have to do with the cause, and they can also have to do with the effect. So let's say, for example, that we're conducting a simple experiment in which we have a treatment and a control. If your theory talks about how the treatment should influence a response variable, perhaps it is going to increase the value of that response variable, such as what we look for in education. We want a treatment that will increase achievement. And so if we're talking about how that treatment will have a positive effect on achievement, if we do not correctly describe the construct of treatment or operationalize the construct of treatment consistent with our descriptions, then we cannot in our study find out if in fact the treatment works the way our theory proposes that it works. So we could have a theory that says, for example, if you can eliminate cognitive distractors, you can increase achievement. And so we have a treatment that is designed to eliminate cognitive distractors, but let's say that our treatment doesn't actually do that. Then the fact that the treatment doesn't work would be due to us not implementing the construct correctly. It wouldn't mean that the theory is incorrect. So the construct in our theory has to be operationally defined in our experiments so that there's a match between theory and how we're performing the experiment. The other major construct evidence we have to look for is when we measure. So if I'm measuring achievement, the measurement of achievement has to truly be measuring the achievement that I'm hoping to measure. If I'm hoping to measure achievement or performance in some unit of history, but in fact the reading level is above the students that I'm using in my experiment, I actually might be measuring reading more than I am history achievement. Our constructs, as we conceive of them in our theory, have to match with how we actually use them in the study, both in terms of how we construct our treatments so that they're operationally defined consistent with our theory, and how we construct our measures so that we're in fact measuring what we intend to measure. Now that part, the construct that we're measuring, has itself a whole array of validity evidences that we have to be concerned with. And that's why we offer entire classes in measurement theory, so that individuals who need to construct measures rather than using measures that have already been validated, people who need to construct those measures know how to go through the processes to make sure that their measurement of the construct is consistent with how we view the construct. So While we're looking here at 4 major types of evidence of research validity, there's a whole field around construct validity that has to do with measurement validity. Okay, so we're not going to get further into that because this is an experimental design course, not a measurement course. External validity has to do with whether what happens within our study is akin to what we can expect to happen outside of our study under the same conditions. So external validity has to do with generalizing our results. You can have a very strong experiment in which you establish cause and effect, you correctly make statistical conclusions, you use good operationalization of treatments, you have good measurement, and so everything you say about what happens in the study, you have good evidence that it is valid. But then the question becomes, okay, if we now step outside of our study, will we find the same thing? It could be that we have a particular arrangement of units or individuals within our study that what we found, we made the correct statements about, but it is unique to what happened within the study. Obviously, if we're conducting research, it's for us to know not just within the study, but outside of the study. So now let's talk about the biggest threats to each of these types of evidence of research validity, starting with statistical conclusion validity. One threat is making a type 1 error, that is, concluding that the treatment is effective when it is actually ineffective, or taking it outside of the realm of experimental design and stating this in more general terms, concluding that we have a relationship among variables, when in fact there is no relationship. That could be something we study with an observational design instead of an experimental design. Now, how can that happen? One would be if we were too willing to embrace the possibility of error. As you know, there's a common standard used in the social and behavioral sciences of 5% as about an acceptable level of error, though there's nothing magical about that. It's tradition as much as anything else, although somewhere along the line, individuals came to see that as low enough to be able to reduce our type 1 errors. There has been a push recently by some scientists, including those in the social and behavioral science, to reduce the traditional level of error to something smaller. But whatever rate you choose, it needs to be a rate that doesn't allow for too many errors. Otherwise, you're going to have a lot of problems with statistical conclusion validity. Remember that when we set our error rate at, say, 5%, or whatever we set it at, 1%, whatever we set it at, if you then conduct your study with that error rate, you are making some assumptions about having met the conditions for valid inference. And if you have not met those conditions for valid inference, then you're not actually conducting your study at the error rate you set. And so therefore, even making a decision that you're going to have a low error rate may not actually correspond to what your error rate is if you've not met those conditions for valid inference. So that's another problem that can lead to a threat to statistical conclusion validity. And then there is the problem of fishing for effects in the data, and this has become a big issue in the social and behavioral sciences in recent years. There have been a number of studies that have brought this to the attention of scientists in many different disciplines. It's known as p-hacking. And what p-hacking is when you collect data on many measures and then look for relationships among all those measures and focus your attention on small p-values. The reason this is a problem is because if we set our type 1 error rate to be, say, 5%, that we expect even when there's no relationship, that 5% of the time we'll detect there is a relationship even when there's not. So imagine if you were to run 100 or 200 different relationships and then pull out the small p-values. That's not necessarily showing you that you have a relationship. That might be showing that you just did a whole bunch of analyses and picked out those p-values that made it appear there was a relationship. So fishing for effects, instead of doing a systematic planned study to focus on effects of interest, such as what we do when we have theoretical based research, instead of just looking at whatever data we happen to have, that can lead to statistical conclusion validity. Then there are errors of the second type, or type 2 errors. And that's when science doesn't really move forward. That is, we conclude the treatment's ineffective, and as you know, we never prove the null hypothesis, so we can say this as, we don't conclude the treatment effective, when it actually is. We say we cannot reject the null hypothesis, we retain it as a possibility, when we should have rejected the null hypothesis. And that can occur when our sample size is too small. When the sample size is too small, we actually have low power. Power is the probability of detecting an effect when there's one to be detected. So if you only have a 20% chance of detecting an effect when there's one to be detected because the sample size is so small, that can lead to a type 2 error. Just like with type 1 errors, if you've not met the conditions for valid inference, you violated the assumption of those conditions, then again, you could have a type 2 error more often than you had planned. If you have unreliable measures, what happens is that you have a lot of measurement error, and that measurement error can create a lot of noise in your data so that you're unable to detect relationships that are there. If you have implemented a treatment in a study in a way that varies from the way it should have been implemented, then of course the treatment may not be effective, and so you claim that the treatment's not effective, or at least you don't have evidence to show it is effective. But why don't you have that evidence? Because you didn't really implement the treatment. That is, you operationally defined your treatment conditions in a way that was inconsistent with theoretical intent. We know that in the physical world experiments, scientists tend to hold everything constant except what it is they're interested in looking at. When we're in the social and behavioral sciences, we can't do that because we're typically working with people. But nonetheless, there are still variables that we can either control or measure and keep track of. And if we fail to do that, then we might have so much variation that we conclude that there is no obvious relationship when in fact there was one that could have been detected. Heterogeneity of participants is one way this can happen. If you have a heterogeneous group, then there is variance among that group even before you measure them. Now, when we talk later about external validity, there's some value in having a heterogeneous group because then you infer to a wider audience. But nonetheless, in an experimental setup, having a heterogeneous group is going to limit the possibility of you being able to detect an effect because it's going to introduce more variation into your study. Now let's turn our attention to threats to internal validity. Remember that whereas statistical conclusion validity is about whether a relationship exists, internal validity is about whether that relationship is a cause-effect relationship, whether changes in variable A, such as treatment control conditions, affect changes in variable B, whatever we're happening to measure for individuals who are in those conditions. The first threat is selection bias. Consider the simple treatment control experiment. If individuals differ in the control group from those in the treatment group with respect to variables that are related to the response measure, then you've got a problem. Because if that was the case, even if you didn't employ the treatment in the treatment condition, you would find a difference without the treatment even being there. That's selection bias, and it typically happens when you use intact groups rather than a good experimental design. If you are using two intact classes to study the use of manipulatives in algebra, it may be the students in one class are of a different mathematical aptitude than the students in the other class. You know, most of the time when students are assigned in high schools and middle schools to classes, it's not random. It has to do with what other classes they are taking. And so you could have that difference that exists in these intact groups. And when that's the case, then when you find a difference after employing a treatment, you don't necessarily know it's the treatment that made the difference because you had a difference ahead of time. History refers to anything outside the study that could be affecting what happens in the study. Let's say, for example, that we wanted to look at the effects of diversity training on the perceptions and actions of individuals in the workplace. But let's say that we implemented our training at the same time when there was an increase in the number of Black Lives Matters protests in the country. That external event that is not set up at all by the people doing the research, but just happens to occur and happens to be related to what the researchers are researching, can influence the results. So when something outside of the study influences what happens in the study, that's referred to as a history effect. A maturation effect indicates that over the time of the study, something may change, again unrelated to the study itself. It might be a natural change that occurs. This is most commonly a problem with longitudinal studies. Suppose we're looking at the development of students from 3rd grade to 7th grade. There are going to be a lot of things that change with the participants in our study that may be unrelated to what we're employing as a treatment in the study, and therefore we will see differences that occur due to maturation that are not due to the treatment, making it more difficult to tease out which effects were due to the treatment. Maturation can go in either direction. It can be a positive change or a more negative change. For instance, if we employ a treatment that after a certain period of time starts to cause fatigue, then fatigue is viewed as a maturation threat in our study. That is, the treatment may not have the same effect that it would have had if the participants in the study had not become fatigued. The testing threat to internal validity means that changes that we observe might be due to our actual measurement of those individuals. This can most often happen when we have a pre-test, post-test situation, and what happens on the pre-test sensitizes individuals so that when they do the post-test, there may be changes because of having taken the pre-test. Similarly, when we measure individuals, it might sensitize them to what we are looking for in the study and change their behaviors in the study. Instrumentation is associated most closely with construct validity. But what we're saying here is that if we don't have the correct measurement of our constructs or the correct operational definitions for our constructs, it's going to make it very difficult for us to understand cause and effect among these constructs. So while instrumentation might be seen as more of a construct validity threat, that has a trickle down to internal validity as well. Statistical regression refers to the fact that when we take individuals on the basis of a single measurement that are at one end or the other of the scale, even without any effect at all, they are likely to tend more towards the middle of the scale the next time that we measure them. So for example, if I want to conduct a study with students who have high aptitude, so I give them an aptitude pretest and I pick out only the students that scored the highest, what happens is that they are near the ceiling of that assessment, and there's only one way that their measures can go the next time they're measured, and that is to go down. They might stay the same, but they may go down. And therefore, we would see a difference from one measurement to the next that had nothing to do with the treatments in our study. Mortality is when there is systematic dropout of the study, such that we end up having a difference from time 1 to time 2 because the characteristics of our samples have changed, and they've changed in a way that is related to our response measures. If mortality is due to just random dropout, it's not as big an issue as if it's due to systematic dropout. If you think, however, about individuals who might be involved in a study and get tired of being in that study, they might be of a certain ilk. There may be something about them that is related to the response measure, and so that their dropout does indeed change the composition of the group in an important way. Diffusion of treatments refers to the potential watering down of the treatment. This can occur when the control condition actually takes on some of the elements of the treatment condition. For example, consider having a treatment in a school setting in which students in the control condition learn about methods of study that are being introduced to students in the treatment condition simply from studying with friends and talking with friends, and they incorporate some of those methods of study into their own study. Then what you have is a control condition that now has elements of the treatment. That is, the control and treatment conditions are no longer as distinct as what was intended. They diffuse into one another. The attitude of subjects can be a threat to internal validity. That's especially true if we have a treatment condition that has some desirable characteristics. Let's suppose that students in the treatment condition are learning subject matter using video games, whereas students in the control condition don't get access to those same games, but they hear about it. That could lead to demoralization, which in fact could then impact what happens in terms of their responses on a post-test. And then implementation again gets back to constructs. If we're not implementing the treatment in the way we intended, that's a construct validity threat, but that's a construct validity threat that will threaten internal validity, that is, our ability to assess cause and effect. Construct validity has to do with whether we are implementing constructs, both cause and effect constructs, in the manner that is theoretically conceived. The first threat to construct validity is strict operationalism or mono-operation bias. This has to do with the notion that constructs are defined in one and only one way. For instance, defining intelligence with an IQ test. IQ test is not a definition of intelligence. It's one way of assessing intelligence. If we only use the IQ test to assess intelligence, then we're actually biasing our construct based upon the properties of that test. In fact, individuals may be higher on the construct of intelligence as we conceive of it, but score lower on an IQ test. Mono-operation bias will associate the construct we're interested in with a score in a way that's not consistent with our intent for the construct. How do we make sure that the constructs are actually being used in a study the way that we intend? We have to explain those constructs very well. And if there's inadequate pre-operational explication, which is a fancy way of saying if we're not explaining them well up front, then they may not be implemented well in our study. So if those who are developing the theories do not adequately give the key elements of those constructs, it's difficult for the researchers studying those constructs to actually use them in the manner they were intended. Along those same lines, a theoretical examination of the data. That has to do with when we collect data without actually having theoretical intent. And as a result, we start talking about relationships that exist and assuming certain constructs are being measured by our data points. But since we did not have that construct to begin with, since we're doing this atheoretically, then we are not adequately linking the actual measurements that we obtain with a construct that normally would be explicated in the theory. When variables are confounded, it simply means that one variable may have an influence on another variable. Therefore, if we're measuring a construct, but within our study there are variables that are confounding our measurement of that construct, then we may end up with a measurement that is not consistent with where the individual should fit on our construct scale. External validity has to do with whether we can take what we observe in the study and use it outside the study. The first problem is sample bias, not to be confused with selection bias. Sample bias means that we're using a sample in our study that has different characteristics than the population for whom we'd wish to generalize our results. This can happen when we use methods of sampling such as convenience samples. Convenience samples will still allow us to have strong statistical conclusion validity and internal validity statements, but those statements are for the individuals in our study and would not pertain to those outside our study if we have sample bias. Specificity of variables is hard to avoid because we're going to have to use some implementation and we're going to have to use some measurements. But what specificity of variables refers to is the fact that we're using certain operational forms of our treatment and certain measures of our construct. You have to do something, so you're going to have to specify your variables. Nonetheless, if you're trying to make general statements about a construct, say aptitude, the fact that you only use certain measures of aptitude is going to reduce your ability to make those general statements. There's no way around this other than to replicate the study using different specifications of variables. You know from your prior statistics courses what an interaction is. Well, treatment interaction effects could be a threat to external validity. Why? Because you would like to generalize the understanding of how a treatment is working on individuals, but if there's another variable that's interacting in your study, then the effects that you're measuring are not going to be consistent when that variable is not present. So whatever takes place in your study, but then one of those variables is not present outside the study, you could get different results in terms of treatment effects outside the study than you do inside the study. Reactive arrangements refers to the fact that when people are being studied, they often react differently than they do when they're not being studied. And so you could end up with different effects in the study than what really would take place outside the study. Multiple treatment interference refers to the fact that once someone has had a treatment, then when they receive that treatment again, they're likely to yield a different result. Knowing, for example, the effect of a drug that you measure within a study will not necessarily result in the same effects outside the study for individuals who are already taking other medications. And then internal validity threats can all be a threat to external validity. Why is that, you might ask? Well, because remember, internal validity is about establishing cause and effect. And if you have a threat to that, but then make a claim of cause and effect outside your study, your claim was not actually correct even within your study, and so it's going to threaten what you say is going to happen outside of your study. Well, that's a lot to bite off. I don't expect you to remember each of these threats. What are the key things that you should remember? You should remember the general types of evidences of research validity, and through reading your textbook, as well as understanding how these different threats can occur, you should understand the best ways that we can address these threats to validity. After all, you're in this class because you want to address threats to validity and be able to produce valid research results. So make sure you understand what the major types of validity evidence are and the general methods we use to address threats to validity, even if you, like me, cannot remember each of these individual threats. We need to know in the main how we can address threats to validity. And then, of course, when we get into our individual research studies, it's going to be more important that we're aware, based upon the type of study we're doing, which of these threats are the ones that we have to consider the most.